Hi, today I'm gonna discuss and do some questions related to definite integrals and how to find the area under a curve. The fundamental theorem of calculus states that if f is a continuous function on the interval x is greater than or equal to a and x is lesser than or equal to b, and f is an antiderivative of f on x is greater than or equal to a and x is lesser than or equal to b, then the integral of b to a of x with respect to dx equals to f of x b to a, the ranges, these are the ranges of x, is equal to f of b minus f of a. Now, in this function right over here, f of x with the ranges b to a is equal to this. And this, when this is solved, it gives the area. When applying the fundamental theorem of calculus, although f can be a member of the family of functions of the antiderivative of f, we choose to use the simplest one, that is one where the constant of integration is c is equal to 0. When we normally derive an indefinite integral, we usually integrate dx to become plus c. But when we integrate a definite integral, we're given boundaries which are the ranges b to a. Therefore, we no longer need the plus c at the end. Therefore, the plus c can be equal to 0, making plus c useless to the equation or to the area. We can do this because for any c, f of x dx is equal to f of x plus c from ranges b to a is equal to f of b plus c minus f of a plus c is equal to f of b minus f of a. Let's practice some questions. The question we'll look at is pretty basic. It is integral of 1 to 0 of 2x with respect to dx. To integrate this question, we first must integrate the 2x on the inside, which will give us 2x squared over 2. Now there's a 2 at the top and 2 at the bottom. Therefore, we can cut them, giving us x squared. Remember, for definite integrals, we do not put the plus c at the end because c is equal to 0. For x squared plus 0 gives us x squared, which is the integration of this. let's set up the equation as per the fundamental theorem of calculus. So, the first boundary of 1, this is the range, is of x squared minus 0 of x squared. Now what you do is you just substitute the 1 in for x, giving us 1 over here and 0 over there. Therefore, the answer to this is equal to 1, which is the area. So, area equals 1. Now let's move on to the next question. Now, the next question is integral of 3 to 0 of 4e to the power of x with respect to dx. What we do in this situation is this same integral formula or integral equation can be written as with 4 on the outside, because 4 is merely just a constant. So once we've done this, we can go on to integrate the inside of the function. Now, the integral of ex is ex. It remains as ex. Therefore, the final integration of this function can be written as 4ex. Remember, plus c, but c is equal to 0, therefore giving us only 4ex. We must put in the boundaries. 3 of 4ex minus 0 of 4ex. What we can do with this is we can take out the 4 from this equation, leaving us with e to the power 3 minus 1 on the inside. Now this equation is equal to the area under the curve of this integral. Now let's look at definite integrals that involve compositions with linear function ax plus b, or the substitution method. Now let's look at a first question. The first question is integral of 5 to 1 e to the power of 2x plus 1 over x squared in respect to dx. Now, let's solve this question. We must first write this in its simplest form. Sorry, 5 to the power 1 e to the power of 2x plus x to the power of minus 2, which is the same as 1 over x squared with respect to dx. We integrate this integral or equation, we will get half times e to the power of 2x minus 1 over x with the boundaries of 5 to 1. We must plug in the two range values into the equation, into this function, using the fundamental theorem of calculus. A half times e to the power of 2 times 5 minus 1 over 5 minus half e to the power of 2 times 1 minus 1 over 1. This can be simplified down to half times e to the power of 10 minus half e squared plus 4 over 5. Or 5e to the power of 10 minus 5e to the power of 2 plus 8 over 10. Now this is the area under the curve.